All right, let's look at part C. You have minus 1 to the n over n ln n. Well, that's an alternating series. I mean, I can go through the guidelines here. I can give tries for other cases, but here in the second guideline, in the second item here, I have the alternating part. The answer is yes. So I want to go ahead and then apply the alternating series test for this problem. Okay. So let's isolate the non-alternating part and call it an. Okay, 1 over n ln n. Okay. First thing is I'm going to look at the limit of 1 over n ln n. Okay. Well, this is a relatively easier limit because the bottom approaches infinity and the top is fixed, so the limit is 0. Okay. In the second item in the integral test, we were checking if an plus 1 is less than or equal to an to deduce that the n term is non-increasing. So let's write an plus 1, which is n plus 1 ln n plus 1. Is this true that ln an plus 1 is less than or equal to an? Well, to see that, well, this expression obviously is bigger than this expression. So you're dividing by a bigger expression on the left, and I can just go ahead and say like check mark by the alternating series test, by alternating series test, the series converges. Okay. So again, since we saw that initially that this is an alternating series, I think it's the best to apply the alternating series test. Can you apply other tests like ratio test or root test or comparison test? Yes, you can. But why don't we apply the alternating series test if we can?